Data analytics is the foundation of AI. Without understanding data, you can't understand or trust the intelligence built on it. This video course is introductory to data analytics for the age of AI. Created by Dr. K. Seefeld. The material used in these videos is in the Text Data Rookie's Introduction to Data Analytics. Available as a free PDF from the website www.dataanalyticscurriculum.com. Chapter 4 Data Wrangling. Chapter 4 Section 2 Data Importing and Exporting. Welcome to this module on data importing and exporting. In this lesson, we'll cover the essentials of bringing data into your workspace and sharing your results with others. Learning objectives. By the end of this lesson, you will be able to import and export data from CSV, Excel, and JSON files. Understand when it's appropriate to use CSV, Excel, or JSON formats. Connect to a relational database and retrieve data. Recognize the benefits of using databases for data management. Why file input, output matters. File input and output, or file I/O, is a critical step in data analytics. After cleaning your data, you need to save it for future use, share it with colleagues, or use it in other applications. Analysts often import data from a variety of sources, including files, APIs, and databases. Likewise, exporting data ensures that your results can be used by others, enabling collaboration and creating workflows that can be repeated reliably. Here are some common data storage types. CSV files. CSV files are simple, plain text files where values are separated by commas. They are ideal for tabular data, with rows representing records and columns representing variables. CSVs are widely compatible, easy to create and share, but they may not be efficient for very large or complex datasets. Excel files. Excel files, in .xlsx or .xls formats, support multiple sheets and formulas. They are common in business and non-technical settings and are easy to manipulate through Excel's interface. Both R and Python can read and write Excel files programmatically. However, sometimes these files require cleanup before analysis, especially if they contain merged cells or extra formatting. JSON files. JSON, or JavaScript Object Notation, is used to store nested or hierarchical data. It's common in web APIs and application data, structured as key-value pairs, arrays, and objects. JSON is excellent for complex relationships, such as user profiles or transaction records. To analyze JSON data, you often need to parse and flatten it into a tabular format. Relational databases. Databases are designed to store large datasets efficiently using tables and keys. Popular systems include MySQL, PostgreSQL, and SQL Server. Data is accessed via SQL queries, and multiple tables can be joined to answer complex questions. Databases are secure, reliable, and scalable, making them ideal for real-time and multi-user environments. Connecting to databases. In R, you can use packages like DBI, RMySQL, or RPostgres. In Python, common libraries include SQLAlchemy, SQLite 3, and Scicop2. The process typically involves opening a connection, writing a SQL query, and importing the results into a data frame. Why use databases? Databases outperform flat files when working with large datasets or real-time data. They support constraints, indexing, and data integrity, and can automate scheduled queries and data extracts, which is essential for consistent reporting. When to export data? After cleaning and transforming your data, you'll often need to export it for reporting or to share with other teams. The format you choose depends on the use case. CSV is ideal for modeling. Excel works well for presentations and business reports. JSON is suitable for web applications or APIs. This concludes the overview of data importing and exporting. Mastering these skills ensures your data workflows are efficient, collaborative, and reliable.